frequency.
Is the P fluid that's times by, is that density?
That is density of the fluid, yes.
And then it's equal to, that P fluid, that's equal to everything, that's the, is that the, pressure?
Yeah, capital P is pressure. Lowercase
Okay.
rho is either momentum or density.
I think it did. More.
Oh, I
Says
just
that
have a
it's
question.
medium
Fact.
Is T
pressure
torque?
Sorry?
Is T torque?
It is not. T is period of oscillation.
Period of oscillation?
Torque is technically lowercase tau. If that helps at all.
So T, period of
Oscillation.
oscillation?
OSCILLATION. I'll point out additionally that not only are there formulas missing from your equation sheet, there's some that you just don't need because this was written as a generalized sheet for most of my classes. If you want to take a look at the ones I've crossed off, you're welcome to do so.
Which ones are crossed off?
Oh, I have it on a sheet of paper.
The ones with the stars next to it, those are the ones we need, right?
You do need the concepts they are about, even if I don't necessarily ask you to use them. Does that make sense? So how you feeling?
Great.
Anything?
Are the ones with the stars that we like absolutely need to know?
No, the ones with the stars, you need to know the concept that the math describes, even if I don't ask you to use that math. Does that make sense? Well, for example,
Know it even though it's not.
right, like let me try to point out an example of what I mean. Here for number 13, this is the practice test. Here we say that a train that makes noise at frequency 200 hertz, according to the Doppler effect, which is the name of the formula on the lower right part of this page, will the frequency that you actually hear be higher, lower, or the same as the train approaches you and separately as the train travels away from you? Now, this formula has a lot of moving parts to it. And the homework never actually asked you to use the formula itself, but I do want you to know what the formula means. So in this practice question, and likewise on the test, what I want you to be able to tell me is that the Doppler effect makes the frequency higher as the object approaches you and lower as the object moves away from you. So it uses the concept of this formula, and you could even use the formula itself to double check your answer if you wanted to, but I don't necessarily require you to get a correct number out of it because the homework didn't require you to do that. Does that answer the question? So for both of those, I put a star by them because the concept they're about is present, even if I don't ask you to use the formula itself to give me a correct numerical answer. But they are still good things to know about. The other one that I've starred here is, oh hey, standing wave. Used. My bad. The other one that I starred there is velocity of sound in air. The main thing I just want you to know about that is speed of sound rises with air temperature. The hotter the air, the faster the sound. That's the only thing I'd ask you to know about that. Okay, and if anyone didn't hear me say this, these are formulas that I believe are missing from the formula sheet, which I do apologize for. And you are encouraged, they will be on the board. I'm not getting rid of these anytime soon. They'll be here all week. But you're encouraged to also write them onto your copy of the formula sheet. And I do plan to post a fully updated version of the sheet before the exam. There's just a couple more formulas to cover first. But I'll also post a separate page that just has all the missing ones if you want to run off one page and still use the formula sheet you've been running with up till now. Bless you. So how you feeling? Main point of today is review, making sure everyone feels confident before test time. Test will again be during lab time, either today, Tuesday, or Wednesday, just depending on your preference. And my plan is to open the floor to you guys for any questions related to the formula sheet or old homeworks, the study list, or the practice test, anything at all that is on your minds. So, what's on your minds?
How many questions?
13. And that is more questions than test one, but each individual question is on average shorter than on test one. Test one, I feel, is about a smaller number of concepts, and so each of the 9 or so questions was longer, but multifaceted.
Yeah.
But on this, since test 2 is about a bunch of different stuff, it's more questions that are each smaller to cover all the topics, but maybe in less detail. Does that answer the question? I've still written it with brevity in mind. I don't want you to take absolutely ages writing everything out. What I mean by that is, on the practice test, I might ask you to define something, because I'd rather you look over the definition while you're studying. But on the actual test, I might ask you instead, is there centrifugal force acting here? Yes, no, and you tell me no because centrifugal force doesn't exist. So, one word answer. Does that make sense? Yes.
So, for force of gravity, like, on this thing, it says like 6,000 kilometers. So we convert that, why not like the 400,000 as a mass?
Good question. Physics is weird in that we prefer meters as the base unit for distance, but kilograms as the unit for mass that we use. And I've never been told an official explanation for that. It could just be that we use bigger masses more than we use bigger distances. But yes, for this formula to work correctly, given all of the constants used that physicists have based the formulas around, you want your masses to be in kilograms, which both of them already are. But separately, you want your one distance, the radius, to be in meters. And whenever you look up the radius of planet Earth or the, something's orbital radius, they always list it in kilometers for some reason. So that does need to be converted into meters for both part A and C before you can use it. Does that acknowledge the concern? Does that at least address the concern? fact, if you wanted to, you could list out like the standard metric units that we use for everything on your sheet if you wanted to. Kilograms, meters, seconds, meters cubed, pascals, newtons, just the standard ones that most of our formulas are built around, if you wanted to. I presume that physicists use kilograms because we are working with objects of mass that are often listed in kilograms, whereas say a chemist or a biologist might be working in grams because they tend to work with small piles of dust.
And for that, do you want us to like, could we just write that, or do you want us to convert to like, let's say like 3.6 to the 10?
But I do not really care. Wait, you mean for the answer?
Yeah.
Yeah, I don't really care which form you write your answer in, the standard form or the scientific notation form, as long as you put your answer on the page somehow with the correct unit and preferably showing your work for how you got there. Frankly, you could not write the answer at all, and as long as you show all the correct work steps, you probably still get an A, the way that I do my rubrics.
Now will the centrifugal force always act as gravity in this?
In the case of space orbit, yes. In space, gravity is what is pretty much always acting as the centripetal force. Now, centripetal force is not always caused by gravity because in several cases, there's something like a string that's doing it instead. Like in the case of physically something swinging around on a string. But in space, orbiting centripetal force is always gravity. It's kind of like how all squares are rectangles, but not all rectangles are squares. They are not on this test.
But they'll be on the final?
They will be on the final. Normally when I teach this class, it's the first test has the laws of motion, and the second test has the laws of thermodynamics, and then the exam has both. But this book doesn't cover the laws of thermodynamics, so the symmetry got thrown off.
So like the definitions of like, that are in the first question would be on
No. On practice test, I usually ask for definitions to get you to check them and write them down. But on the actual test, my concept questions are usually looking for 1 or 2 word answers. So I might ask you, like rather than asking you to write out centrifugal force, I might ask, is there a centrifugal force acting in this scenario? Yes or no? And your answer should be no, because centrifugal force doesn't exist. Yeah, precisely. I'd say a pretty good example might actually be 4. Because in this case, I give you the words and you just have to put them in the right spot. The idea being I want to write the test questions so that time is not a limiting factor. I want you to be able to get through it quickly as long as you look at things and know what to do, and then you just get the questions done and over with and move on. You guys feeling?
So is gravity that, is it the 10?
Oh, that G?
Yeah.
Yeah, lowercase g, you can always use 10 in here. Lowercase g is 10. The absolute value here just means that you don't care about the negative in this formula. This formula only really wants to know the strength of gravity on this planet. There's a couple formulas that are like that. I try to put the absolute value brackets in on the equation sheet. So you, in this case, would probably end up using positive 10. That is the question. Okay. Yeah, so small g, you can use 10, or 9.8 if you want to be specific. And then if I ask you about a force of gravity that isn't on planet Earth, you probably want to use the big formula.
Scroll down, slow it to 5 because I can see the.
And if my chicken scratch handwriting is ever indecipherable, please call me out on it.
Okay. Why did you do .45? So I just
Because we tend to prefer meters over
Yeah, you
centimeters.
said that.
Kind of for the same reason I converted kilometers into meters for the big gravity question.
Okay.
This formula specifically would actually need them so that you successfully cancel out, bless you, the meters that are in 60 meters per second.
Mm-hmm.
You'd want meters per second here and meters here so that everything technically cancels correctly.
Okay.
What's the unit for, W equals 133.3 repeats? What's the units? I can't read.
Yes, that is radians per second, so that's supposed to say rad, but somehow my D kind of looks like a mutated V. So yeah, that is rad for radians, which is also what this is supposed to be.
We was on the test, and we weren't, are we getting between 45 and 45?
If you used 45,
Cause you got like, if you use 45, you just got instead of 1, 2, 3.
yeah, like that wouldn't be a huge deal. Like if it was a 10-point question, that might be worth 1 out of 10 points if you just made that small error. And if you then got 1.3 repeating here, no, you wouldn't have any other problems moving forward as long as you took that answer and then used it correctly in the following part. Yeah, conversions are usually like 1 point or half a point whenever I count them. Same with units. You should put units on your answers. It's not the end of the world if you forget to, but the half a point adds up every so often.
What is that undergrad in for B? At a 5?
This,
Yes.
that is supposed to be an S for seconds. My handwriting's awful. Please call me out on these things. And it's supposed to be radians per second so that multiplying by this cancels out radians and leaves in rotations, and then this cancels out seconds and leaves in minutes. I have found that my handwriting improves, at least marginally, when I'm writing on the board because everything's bigger and I have more space. But this is technically, like 1/4 of the page where I was scrolling out an answer key zoomed in. So that's me being self-conscious. I feel like this is not an example of my best work when it comes to penmanship, given the restriction of it having been written small in the first place. How you guys feeling?
Yeah. That's it. For 9, instead of doing the first part, like PVD, could we use like the density formula to solve it? Like if I did 100, like 1,000 equals to 500 divided by V, and then times V to where it says like 1,000 times V equals 500, making it 0.5.
Yeah, that would give you the same answer. Basically,
I just didn't see that.
that's not always, like that's kind of like the shortcut. Therefore, it's not the method I endorse, technically speaking. But that does work. Basically, the part of buoyancy is that the weight of the displaced water is equal to the buoyant force generated. Because if you push 2 pounds of water out of the way, it's going to push back with 2 pounds of force to try to take its space back. And so, what you were just saying, using the density formula as a shortcut, is basically trying to figure out what volume of water would have the same mass as the 500 kilograms of steel. Which does work. That absolutely works in this specific case. Basically, you're just kind of cutting out the middleman of finding weight and then factoring G back out of it.
I was just saying, like, if that would work, because it worked in this case. I was just saying, if it didn't work in every case.
It would, I'd just be careful, because you want to make sure that you'd be using in that case the mass of the object, the density of water, and the volume then would be the volume of water displaced, which would be the volume of object under the water's surface. So, if you wanted to do that, density fluid equals m object total over volume object submerged. As long as you were very specifically using those 3 variables, that should work. But yes, you have noticed the pattern.
I just saw it on the, because I didn't see the one that you used on the formula sheet.
Oh.
It could be.
Yeah, buoyant force is under Archimedes' principle, FB equals, etc. Next page. There. You can relabel it buoyant force if you want. Yeah.
For number 5,
Mm-hmm.
would it be wrong if you use the equation from the angular side?
It would not be wrong.
Okay. Would it be the A one?
I wouldn't recommend using that one because the object in this question isn't accelerating. That letter A stands for angular acceleration, which we didn't really use. And in this specific case, the vehicle is moving at constant speed, therefore the wheels are spinning at constant speed. So there's technically no accelerating going on, and therefore technically all three of these, since they have an A in them, would end up being 0. It's definitely related, like those are the angular formulas, but
I use the second one,
Mhm.
and then just put 60 as A, and then 45 at the top, and then I just divide it 60. That's how I got multiple.
Okay, now I want to possibly address your algebra there. That's not in here right now. There we go. Now, first of all, I want to stress that this formula, as it's currently written, doesn't work in this situation because there is no angular acceleration, therefore this should technically be 0. This is then the passage of time, and this is the change in angular velocity. And technically angular velocity isn't changing. So first note, this is the wrong formula for this situation. Second note, if you plug everything into the spots that you mentioned, 60 equals omega over 0.45 plus 0. Now, ignoring that for a second, if this is what you have on your paper, technically, if you wanted to get the W by itself, what should you do to both sides? Multiply. So this then would actually give you 60 times 0.45 equals omega, not divided by. So it's the wrong formula for a couple of reasons. Main things, I don't think I actually used this one at all. I don't even think I covered it in lecture. And doubly make sure you are tracking your multiplication and division. Oh, yeah.
Can you go over the relationship between radians and rotations?
Yes.
Two.
Radians and rotations are two different units for the same thing. They're the same relationship as feet, meters and feet. I almost said feeders and meat. Meters and feet. So these measure the same basic thing, therefore you can convert one directly into the other. One full rotation, 360 degrees, is equal to a number of radians equal to 2 pi. So 2 pi is the number of radians that you fit into one full rotation. using that to actually convert something. Yes. So in part 5B, for example, I use that as a conversion. I've got something in radians per second, so I use 1 rotation over 2 pi radians in order to cancel out radians and leave behind rotations per second or rotations per minute. And to do that correctly, 2 pi is the number that goes here. So you would divide by open parentheses, 2 pi close parentheses, in order to do that right. Does that help?
Yeah, thank you.
How you guys feeling? Yeah.
Is there no net torque? 'Cause it's
Correct. The rule for net torque is if the system isn't rotating, then it is in rotational equilibrium. And rotational equilibrium automatically means net torque is 0. The same exact way that if an object is in normal equilibrium, it's not accelerating in any direction, then the net force on it must be 0. It means the same thing, it's just normal equilibrium involves moving in a straight line, rotational equilibrium involves not spinning. And since then, net torque is 0, all 3 of the torques in the system must add up to 0.
For the period equation, when T is time over number of months, is the unit just seconds?
Yes, the unit for period of oscillation is seconds. Because number of events isn't really a unit, it's just the seconds that it takes for an event to take place.
Okay, thank you.
You're welcome. Just out of curiosity, how many people are planning on actually taking the test today specifically? I figured. For some inexplicable reason, most of my students just choose not to do it on the Monday. Can't figure out why. So, overall, how you guys have been feeling with this study session? Just to keep everyone posted, the time is currently 12:11. I'm going to be here regardless. If you have more reviewing you want to do, or want to stick around in case a question pops into your head, you're more than welcome to. But if you feel satisfied with the level of review for right now, you are also welcome to go do whatever you need to do, such as eat or travel to a more comfortable location. If you need anything, I will be either here or in my office. And please ask your questions literally anytime, as per usual. And if I don't see you later today, have a wonderful day.
Wednesday is also just a study session. So we already take the
Yeah. But do come on Friday, because I'm hopefully going to be giving her what it's back.
Okay.
You're welcome. Wednesday is more review. If you don't need the review, then you can sleep in. Friday though, show up as normal. I'm gonna be giving you a test tonight.
Have a good day, sir.
Have a good day and thank you.
You too. Appreciate you guys.
Last room on the left. I meant to ask, given just lab stuff,